AMC 12 2023 problem 5. You are playing a game. A 2x1 rectangle covers two adjacent squares oriented either horizontally or vertically of a 3x3 grid of squares. But you are not told which two squares are covered. Your goal is to find at least one square that is covered by the rectangle. A turn consists of you guessing a square, after which you are told whether that square is covered by the hidden rectangle. What is the minimum number of turns you need to ensure that at least one of your guess squares is covered by the rectangle? Okay. When you want to find minimum or maximum of something, the idea is to consider the range. And one part is you should, for one side, you should find example. For the other side, you should prove. Here, which side is related to example? Because it says minimum, if you find an example, a good example, the answer will be less than or equal that. This one side is related to proof. So, if you have a 3x3, let's go through this one. Okay. You can check different cases, and for example, one thing is this. You can ask this one, if it is yes, okay, by one question. If it is yes by one question, maybe no. If it is yes, you will find. If no, then you see this square satisfies, but it says you should ask this one. It is so much important. Pay attention, because if you don't pay attention to this, you will find the answer. Your answer will be one less than the real answer. It says you need to ensure that at least one of your guessed square is covered. So I should guess this one, and then I will see, okay, it will be covered. Because why? If it is no, then suppose this one is no, this one is no, this one is no. The only possible 1/2s are these things. All of them have a common cell, this one. So you can ask this one, and this one has to be yes. So answer is at most 4, at least 4, at most 4, because we found an algorithm, a strategy to reach the correct one, to reach the goal by 4 questions. Now, by 4 questions here, now I want to prove 3 is not possible. Okay, now let's prove how we can say the answer is at least 4. Suppose if by 3 questions we can find, for example, the correct cell, you should ask one cell from each row, because if you don't ask, for example, the first row, then maybe our 1/2 is in first row. Okay, and also if you want to reach the answer by 3, then you should ask mid one here. Okay, because if you ask only this one, maybe the 1/2 is here. If you want to reach, you should ask this one, this one, this one. But here we have problem, because we can say same thing for columns. Or we can say, okay, maybe 1/2 is this one or this one. So if answer is 3 or less than or equal 3, less than or equal 3 is not possible, because you should ask each row at least once. If answer is 3, you should ask mid cells of each row. Also similarly, you should ask mid cell of each column, which is not possible. Or you can say you should ask mid cell of each row. So you should ask like this, and then we have these things that you've not asked yet. So we prove the answer is also at least 4, so the answer is 4. If you want to solve this approach, is so much useful. Answer at least what, at most what. Okay, and before the exam, I released many videos in BMO, in AMC, that this idea was useful. If you want to know important ideas and combinatorics at other topics, feel free to send message to my WhatsApp number in the description.